Welcome, Algebra 1 class. This is the first homework that we're going to look at, section 1.1, and it's entitled The Real Numbers, as opposed to unreal numbers, I suppose, but the real numbers. It's a class of numbers. There are different types of numbers in the mathematical uh, sphere, and we're only going to study the real numbers. Those are numbers that we can actually think of, that we can actually view in our minds. We can imagine what 10 means. We can imagine what 5 means. We can even imagine what -5 means, especially when you're dealing with money. Okay? Having -$5 in your wallet basically means you have no money, and yet you also owe $5 to somebody. So we have, those are real life experiences to things that we're familiar with, and those are the real numbers, and that's all we're going to deal with. This course, for a lot of people, is going to be difficult enough without getting into other types of numbers. You get into those in upper level classes. At any rate, we're going to introduce you to positive and negative numbers. A lot of people know what that is already, but I'm going to assume you don't, and I'll try to give you my my view on how to represent a positive and negative number. Like, we're going to take a look at this problem here and express this quantity as a positive or negative number. Okay, you're on a quiz show, Jeopardy, and a person loses 1,800 points. I would say that's a pretty negative number. Okay, when you lose something like that is negative. So I would represent that 1,800 as a negative 1,800. Okay, so I type that into the box if people aren't familiar with the system, and we'll check our answer. You'll look at some nice green box that says I'm fantastic. Okay, if I got that wrong, then I get a red box that says try it again. You have, like, I think 3 or 4 tries, or certainly 3 tries to add a problem before it marks it wrong. But even then, you can ask for a similar question. I'll get the next ones purposely wrong and show you what happens in the system. Okay, a record low temperature for the date is 17.9 degrees below zero. Below zero. That must mean negative. But I'm going to put down 18. Has nothing to do with that number. Negative 18. Check my answer. Below means the number will be negative. You see, it tries to help you out. But I'm insistent that that number is 18. Check my answer. No. Final check. 3 tries. Correct answer is that. Then you have a similar question. So it's not like things are all bad. If you don't understand something, give it a try. Keep trying and trying and trying. Eventually, it might sink in. So let's do a similar question. And they're saying, well, the record low temperature for a date is 24.1 degrees below zero. So that must be negative 24.1 degrees. Right there, I got it right. And so don't worry about the things you got wrong. This correct answer overrides the problem. See, I got a little check mark there. That went away. Boy, they really don't want to give you any positive numbers here on the sample test. So during the quiz, a person loses. You know what? Yeah, everything was negative. There will be some questions that they'll ask you that will be positive. I just was lucky enough to get negative answers here. Anyway, this is going to be fun. Graphing, a little bit of graphing. See, this is called the number line. Okay, and the center of the world of that number line is called the origin. It's the 0 point. It's got no value. Things to the right are positive. Things to the left are negative. So that 0 divides the world into a positive land and negative land. And so as you go along here, you can tell that if you compare 2 numbers, 9 and 7, you know intuitively 9 is larger than 7. So anything to the right of another number is bigger. Now remember what I just said there. Anything to the right of another number is bigger. Try what happens here. Look at this. -6, -4. -4 is to the right of -6. It is bigger than -6 in value. And if you think about it, think of it in terms of money. As you go down this side, -$1, -$2. You go to the casino, -$3. They give you credit, -$4. Okay, they give you more credit, -5, -6. They stop giving you credit. Okay, wouldn't it be better to be -$4 in the hole as opposed to $6 in the hole? That's why -4 is bigger than -6. Anything to the right of another number is bigger. But I even gave you more than you need for this problem. I've been giving you a little background as to what you're going to do for this section. They want us to graph -1/4. So I'm just clicking with my mouth, holding the button down, and it's allowing us to move it around. I'm going to search for -4. Right there, right there. I let go of the mouse, and the point's planted there. Check your answer. That's it. That's great. Now, what I'm doing here in terms of lecturing is I'm going through the homework and trying to point out the things that you might get hung up on, the high points of the problems. Sometimes I'll deviate from the problems and explain things that you should know. I'm not afraid to show you these problems because these problems are going to be different for every person that looks at these problems. So I might get a number 6, you might get the number 33. Who knows? It's all random. So I have no problems going over these questions in front of you. And hopefully this will help you. You have this video. You can go back and see, well, why did I pick that? You know, I'm on problem 5. I keep getting number 5 wrong. What did Professor Silvestri do with problem 5? So this is the way the course is going to run all semester long. Okay, let's do it. Numbers can be classified. Okay, -6. Is it a whole number? Now, a lot of people would say yes, it's a whole number because there's people were taught that if there's a fraction or a decimal to that number, it's not a whole number, but that's not really true. A whole number has no negativity. There's no negative numbers in whole numbers. Whole numbers are basically the counting numbers, where you start counting things. You don't count from -5. You count from 0, 1, 2, 3, 4, etc. Whole numbers that start from 0, that's considered the whole numbers. So I'm going to say that is the negative number is not a whole number. It is an integer. Any integers take into consideration negative and positive numbers and 0. Okay, so but they can't have decimals. They can't have any fractions associated with them. A rational number, it is a rational number. A rational number is a fraction. Okay, you say, well, Professor Silvestri, I don't see any fraction here. You know, -6 can be written as a fraction by just saying over 1. Now, I would never do that in real math because -6 is easier than writing this. But technically, -6 is a rational number, and a rational number is a fraction. It's a fancy word for a fraction. And everything that we do in this class is a real number. Okay? Everything is a real number. So this will always be yes. Check your answer. Nice. Okay, then there's a problem 6. Okay. Well, this is definitely not, it might be positive, but there's a fraction associated with this number. So this is not a whole number. It's not an integer. It is a rational number. Okay, because I could represent 2 1/6. Remember this? 2 1/6 is equal to, well, 6 times 2 plus 1 is the numerator over 6. So 13 over 6 is 2 1/6. And it's a rational number. Anything that can be represented as a numerator and denominator is a rational number. And so, yes, it is. And everything's a real number. Everything's a real number. Check your answer. Nice, nice, nice. Now, there's some operations you have to understand in math. One of the basic operations is the opposite. Now, it's a very simple operation. The opposite of a -8 is a +8. Just change the sign. That's all you got to do. The opposite of a number is If it starts off as positive, the opposite is negative. If it starts off at negative, the opposite is positive. That's it. Now, plus 8 is not necessary. I believe the computer will probably take it, but it's implied that if there's no sign, it's positive. So that's the opposite. Don't read into it any more than what I just said. Just change the sign to something else. Okay? We have a negative 3.7. What's the opposite? Positive 3.7. That's all. That's all it is. Now, this guy here, this is called the absolute value. Okay? Absolute. I get reduced to my chicken scratch here. I'm sorry, but this is the way it is. Absolute value. And absolute value is always positive. Is always positive. Plus is always positive. And it's 2 vertical strokes. That's the symbol for absolute value. And what's inside is the thing that you want to take the absolute value of. Now, the absolute value strips the sign from the number that's inside it. Strips the sign. So if I take minus away, the value is 8. If I start off with 8, the absolute value of 8, that's also 8. It's implied there's a plus there. I strip the sign. I throw away the plus. It's still plus. So understand, it's not the opposite. This is not the opposite. It strips the sign. Okay? That's the operation for the absolute value. It strips the sign. Always positive. Never negative. Now we're going to be halfway done. What do you think this is? 9.6. Strip the sign. Remove the sign. Always positive. Halfway done. Now, be careful here. Okay? We take the absolute value. See, the negative sign is not inside the operation. It's not inside those vertical bars. So what you're basically doing is you're taking the absolute value of 1/7, which is 1/7. Okay? And then what you're doing is you're negating it. You're making it minus. This is minus 1/7. Okay? Only because, let me see if I can fit this sort of on the bottom here. Only because, see, this is right over here. You have actually 2 operations going. Okay? The minus has nothing to do with what we're asked to do inside here. That says strip the sign of 1/7. Well, that's very easy. It's already stripped. Okay? Then you negate it. That's a big minus sign. Let's erase that. Okay? Then you put a minus. Then you negate it. Make it negative. That's a separate operation. Okay, next question. Name all the numbers that have an absolute value of 9. There are 2 numbers that have the absolute value of 9. Certainly 9 does. And comma, -9. Both those numbers have an absolute value of 9. Use a comma to separate the answers. Understand that. Fantastic. I'm going to let you do that. Ooh, whoa. I'm not going to let you do this one because this is a trick question. Name all the numbers that have an absolute value of -6. No, not on this earth. Okay, their absolute value is always positive. Say that with me. Absolute value is always positive. Okay, and it's never negative. That is just, it's not right. B's got to be the answer. Okay, trick question. Now we have to determine whether something is less than or greater than. These are the less than sign, and the arrow points to what is supposed to be the smaller of the 2. Okay, so what I'm going to do is draw a quick number line to refresh your memories how to do this. I'm going to do a new virtual sheet of paper. I'm going to go ahead and say new. Okay, there's a nice blank slate. And to do problems like this, here's my number line. You don't have to be fancy. I certainly am not fancy here. 0, 1, -1, -2, -3, -4. That's enough. I'm bored already. -3 is over here. Right there, that's -3. -1 is over here. Anything to the right is bigger than to the left. -1 is bigger than -3. That's true. That means the same thing, okay? This and what I have on the screen are exactly the same thing. If you were to switch these numbers around, okay, the less than points to what's supposed to be the smaller of the two, you need to change the direction of the arrow. So certainly, the top reads -1 is greater than -3. You can also say that -3 is less than -1. So that's true. Not many more. Not many more here. 0 is greater than or equal to 1 1/3. Well, no, of course not. Here's 0. 1 1/3 is over here. Okay, 0 is less than 1 1/3. Okay, so it's less than. It's not even, nowhere near greater than or equal to. False. Okay, now replace. Okay, 5 being a positive number, it's got to be bigger than any negative number. You don't need a number line for that. Positives are always bigger than negatives, because they would be plotted to the right of any negative number. So 5 is greater than -5, and I selected that. I completed the statement. Yeah, excellent. -1.2. This might get a little tricky. Okay, let's delve into that a little bit. I'm not even going to worry about the positive end. I'm going to say that's -1, -2. Okay, that's enough. I just want to focus in on the values there. -1 is over here. And the best I can write is say -1.2 is maybe a little smidge over here. Okay. -1.2 is less than -1 because it's to the left of -1. So, come on. Is less than. It's okay. This is a bigger number in the negative direction. A bigger number in the negative direction is not good. It makes it more negative. Has it less value. Well done. 3 more. 9.5 is equal to 9.5. Well, just do this. The 9s are the same. Okay, this is 0.5. The fraction represents the decimal. So if I divide 2 into 1, it's 0.5. So it's 9.5. So they're equal. They're just different representations of the same thing. And then, let's see, order the numbers from largest to smallest. That means go down, a descending order. So what's the largest number you see here? I'm feeling 5.5. The next largest number is number 2. The next number is not -8. The next largest number is -3.5 because it's closer to the origin. It's closer to the origin than -8, which is farther away. I'm going to say that that's the right answer. And last is the three. Okay, 3 of the coldest temperatures ever recorded are -59.2, -57.1, and -55.1. What's the coldest temperature? The coldest temperature is the one that has the biggest negative number. That's the coldest temperature, because if I were to plot that number, it'd be plotted farther, farther, farther away from the 0, which makes it the worst. -59.2. Now the hottest would be, if you can consider this hot, -55.1, because that would be plotted closer to the 0. It's got a less of a value, but that's good when you're dealing with negative numbers. Okay. So let's see that. Well done. And that is that section, homework 1-1. So get this homework done as soon as possible. And we'll see you in the next homework assignment where we're going to start learning how to add positive and negative numbers. All right. We'll see you then. Bye.